Welcome to qnawire.
So here, let's redraw the diagram for the basically the pool, and we can say that if this would be the starting position of this would be the position of the drowning swimmer, and then this would be the starting position of the lifeguard, going straight down to the right. The lifeguard is going to walk some distance before jumping in the water, and then at one point he's going to jump in the water and swim directly to the drowning swimmer. We know that this distance here is capital D, being 8.0 meters, and we know that this distance here is lowercase d, being 10.0 meters. And so we can say that for each segment of the path, this being delta x, we can say that for each segment of the path, the time is given by the distance divided by the speed. So the time it takes for the lifeguard to reach the swimmer would be equal to the time it takes for the lifeguard to run on land plus the time it takes for the lifeguard to swim. This would be equal to the distance on land divided by the velocity on land, plus the distance in the pool divided by the distance, the velocity in the pool, the velocity at which the lifeguard can swim. And so we can say that t is going to be equal to x divided by the velocity of how fast the lifeguard can run, so v sub r, and then plus we're going to have to use Pythagorean's theorem, and we can say that we can create a triangle here, and we're trying to find this distance here, this hypotenuse essentially. So we can say that this would be plus the square root of d squared plus d minus x quantity squared, and then this would be divided by the velocity with which the lifeguard can swim, so v sub s. And so that would be how we would prove the time taken to get from the lifeguard to the time taken to get to the swimmer from the starting position of the lifeguard. For part B, this would be the graph. So we can model this, and we can say that in order to minimize the time to get to the drowning child, we need to take the minimum of this graph, and essentially it would occur approximately right here. So we're going to say that this is 6.8. Therefore, T min occurs at x equaling 6.8 meters, which means that essentially you should the lifeguard should run 6.8 meters before jumping into the pool in order to minimize the time taken in order to get to the child. So this would be our answer for part B. That is the end of the solution. Thank you for watching.